Okay, so just to review here, we're finding domain, but really important as we work with more algebraic and less graphical stuff here. So the domain is the set of inputs which produce a defined output. So if you can plug in the x value and you can get an answer that's a number, it could even be 0 or it could be negative or positive or a fraction or whatever, then it's a part of the domain. The things that are excluded from the domain are the things that you plug in and cause the answer to be undefined. Right? So we need a defined output. Undefined is not defined. So there's multiple reasons we can exclude things from the domain, but really the two that we know about at this point and we've worked a lot with are if an x value causes you to divide by 0, it can't be a part of the domain. And if it causes you to get a negative under an even root. So usually it's going to be a square root, but it could also be a fourth root. Again, that doesn't apply if it's an odd root. So those are the two things we're going to look for. So today, when we find domain, we have example 1 here. What we'd like to do is write a couple inequalities, solve them, use those to make a number line, and then use the number line to make interval notation. As you get better at this, you'll realize what the interval notation looks like for a lot of these, and you can maybe skip that step. But unless you're really confident, I would still today, probably for everybody, I would go through all these steps. Make sure you write them down. That way, if you're reviewing for it in the future, you can look back and it makes sense to you. So here's example 1. We have f of x equals the square root of 3x minus 9, and we're divided by x squared minus 9. Okay, right away, I see that I have a square root, right? So that's going to give me a restriction. Now we probably know too that this is factorable. This will be easier to look at if it's factorable. So I'm going to go ahead and write this as f of x equals the square root of 3x plus 9, didn't change anything, and then x plus 3, x minus 3. Okay. Now, I can see again, this is still a problem, and then these two places would cause division by 0, correct? So in this case, I know that 3x minus 9, which is under a square root, needs to be greater than or equal to 0. Right? We can take the square root of 0. That's fine. We could take the square root of any positive, but we can't take the square root of a negative. And then we know that x plus 3 cannot equal 0, and then x minus 3 cannot equal 0. So we actually have 3 kind of statements that we have to investigate here to find our domain. To solve an inequality, remember it's the same process as solving an equation with one big exception. If you multiply or divide by a negative number, you have to reverse the inequality. Okay. So it's always probably a good, maybe when looking at your answer, then you kind of check it back against the original if you're afraid you may have forgotten that. So in this case, we'll add 9 to both sides. Right? 3x is greater than or equal to 9. We'll go ahead and divide by 3. So x is greater than or equal to 3. So that's a statement that we need to respect. This next one here is x plus 3 is not equal to 0. Whenever you have a not equal to, you can solve it just like an equation. It solves the same way. So subtract 3, we get x is not equal to negative 3, and then here x is not equal to positive 3. Okay. So these are the 3 restrictions, or these are the 3 things we have to incorporate in our domain. So at this point, I'm going to make a number line. And I'm only going to draw the things that I'm interested in. I'm interested in 3 and negative 3. It doesn't have to be, it's just a tool, right? It's not a final answer, a real fancy number line. So with this, these two things cannot happen, correct? So the way I'm going to indicate those first on my number line by putting open circles at negative 3 and at positive 3. And I just have to remember I can't fill those in. Those are open circles. Okay? And the next part we have, so that took care of these two, then x is greater than or equal to 3. Well, if I was just doing that, I would put a closed circle and shade to the right, correct? But in this case, I just said it has to be open. So I'm just going to start at that open circle and shade to the right. So this number line shows us our domain. Now, this is not shaded, so is any of this included in our domain? No, and negative 3 is still not included, so it's just out, right? And then 3's out, but everything to the right of 3 is true. So if this is x is greater than 3. That's how you could write it. But in terms of interval notation, x is contained in, if you want to get really fancy, and again, this is our domain. I'm going to put parenthesis 3, comma, infinity, parenthesis. I put a parenthesis next to the 3 because 3 is not included. And then I put a parenthesis next to infinity because I always do that. And then, again, always remember smaller number on the left, bigger number on the right. Okay, now for our second example here, we have g of x equals x minus 1 divided by the square root of x minus 1. Little different here, but for this one, does the x minus 1 on top cause any domain problems? I could take any number I want and I could subtract 1 and I'll get an answer. So we don't have to worry about it. Now on bottom, we got a couple things. We have an expression that we should say can't equal 0. We also have a radical. The piece underneath it's called the radicand, technically, is how that goes. So what we want to do is we'll say whatever's underneath the radical, in this case x minus 1, needs to be greater than or equal to 0. But if this is equal to 0, do I have a problem here?
Yes.
Yeah, so if you realize that right away, you can just say greater than 0 and do it all in one step. Okay? Suppose we didn't, though. Then also, you'd have to say the denominator, radical x minus 1 cannot equal 0, right? Because there is a denominator. Now, again, we could have done this a little more efficiently, but let's take a look here. To solve this, I'm going to add 1 to both sides. Remember, the only weird thing about inequalities is if you multiply or divide by a negative, it flips. Otherwise, it's cool. So x is greater than or equal to 1. To solve this, if it's just like an equation, let's just square both sides. Right? A square root squared is just whatever's underneath it. It's not equal to 0, and then x is not equal to 1. So see, if we would have left the equal out, we would have been fine, but we could write it as 2 pieces also. So on our number line, I have 1, and I have an open circle at 1, right? That's the not equal to, and then x is greater than or equal to 1, but we said it can't be equal, so it's just going to be greater than. Since it's just greater than, our domain then will be x is contained in the open interval from 0 to infinity. Open interval just means they're both parentheses. Just a weird, I threw that in there for fun. Why did I put 0 though? That was just bad. How about 1? 1 looks a lot more correct. So that one. Okay, so on the back of this worksheet here, the first one is f of x equals x squared plus 6x plus 5. Now we talked about continuity and things before, and to figure out on our last assessment that if you wanted to figure out if it was an infinite or removable discontinuity, you'd have to factor the numerator. But if we're just asked for the domain, we actually don't have to. Because all we're going to do is look and say, is there any radicals in here? There's not. Is there anywhere that could cause me to divide by 0? That would be right here. So we're going to say the divide by 0, so we say x minus 1 cannot equal 0. X cannot equal 1. That's it. So our number line is completely filled in with the exception of 1. Right? So our domain in interval notation. Yep. What goes next to the 1s?
Brackets.
Bracket. No, it's a parentheses.
Parentheses.
Union. Infinity 1, parentheses union.
Yeah. This is what, so just make the connection here. X cannot equal 1 is an inequality, right? And that's the easiest way to write our domain. If you're asked to write an interval notation, it will look like this. It's not as easy as you'd like to write it that way, but we can do that. Okay, so that's that one.
I really thought it was a bracket.
Now this next one, we have g of x equals the square root of x plus 4 over x. So do we have a radical?
Yes.
Yes. Now that's going to be our greater than or equal to, correct?
Yep.
Is greater than or equal to 0. Now what about the denominator?
X is not equal to 0.
not equal 0. So that's just done, right? Just got to remember that. So for this one, we can subtract 4 from each side. X is greater than or equal to negative 4. Now, I would recommend still making a number line if you have at all any doubts about what the interval would look like. So I put negative 4, I put 0 on here. I know 0 has to be open. So I'm going to go ahead, whatever I know can't happen, I'm going to mark on there right away. 0's out. And then x is greater than or equal to negative 4. That would be a closed circle here. We'd shade to the right, but we're going to skip 0, and then we continue shading to the right. So we get this picture. Now what you can do is every time there's a break, it means you're going to start a new interval. So our first interval is going to go from negative 4 to 0. Closed circle tells me bracket. 0 tells me parenthesis, right? Open circle, I always think if you cut an open circle in half, it looks like a parenthesis. And then union, 0 to infinity. So that would be our domain here. Okay, so then for the third example on the back here, we have the square root of x minus 3 in the numerator. That's going to mean something. And then we have x plus 4 on bottom, which is going to mean that we have a restriction. So remember, the radicals give us a less than or greater than or equal to sign, correct? Maybe remember, it's got a little V-shaped piece, and it gives you a little V-shaped thing, maybe. Hold on. So x minus 3 is greater than or equal to 0. And also x plus 4 cannot equal 0. This came from the underneath the radical. This came from the denominator. Okay, so now at this point, we're going to add 3 to both sides. So x is greater than or equal to 3. Here we solve, and we get x cannot equal negative 4. Now, poor negative. I always feel bad for negative 4 in this problem because it's just really, like it has to be, it can't be an answer, right? But then when I shade the rest, I get a closed circle and I shade to the right. I get it. It has the unique ability that it fails both parts, right? It's like a 2-time loser or something. I don't know. But it's out. An open circle in the middle of a non-shaded line just means nothing. Like it doesn't mean anything. So to write this inequality, we'll say the domain goes from 3 to infinity. There we go. Right? It's bracket though, bracket 3 to infinity. Now this last one here, the first part. Now, are we to the point now, hopefully you look at this and you're like, well, negative 6 is out.
Yeah.
Right? So we write that. X plus 6 cannot equal 0. X cannot equal negative 6. We got that. The next part is x squared minus 9 is greater than or equal to 0. We can't solve inequalities if they're a quadratic the same way we solve an equation. It just doesn't work. There's another technique. You make a sign table, you test intervals. We'll do it. We just haven't done it yet. But what I would do on this one, and we could do this a kind of an easier way, is this, if you think of it, is a graph. Right? If we think of the graph of y equals x squared minus 9, it's saying when is that greater than or equal to 0? Now, do you know what this graph looks like? It's a parabola, right? And it actually has x-intercepts at 3 and negative 3. So if you think about this graph, it's got out here at 3, 0, negative 3, 0. Down here you're at 0, 9, right? Or negative 9 for the vertex. So if you look at this, where is it above? When is it greater than or equal to 0? Well, that would be all these places, correct? That would be when x is 3 and larger, and when x is negative 3 and smaller. Yeah. So for this, we would say that x is less than or equal to negative 3 or greater than or equal to positive 3. Does that make sense with that? And if you test numbers too, you could graph this on your calculator if you wanted to, but that was a pretty easy graph to do by hand. Okay, so let me real quick just finish this up and then. So in terms of our number line, -6 is out. Open circle, it's out of the game, right? Can't do that. Now -3 and 3, x is less than or equal to -3. That would be a closed circle going left. And then here is an open circle going right. Again, 6 was left out. So with this, that's a picture of our domain. Okay, that's a picture of our domain. So that's going to be,
That'd be negative infinity to -3.
no, we're going to go negative infinity to -6 because we have to leave the -6 out.
Union.
Union, -6 to -3
Bracket.
bracket. Union,
-3.
positive, because I'm just going like so, negative infinity, -6. If you load, those will all show up down here. So it's going to be 3 with a bracket, infinity with a parenthesis. That would be our domain there. Okay.
Is it bracket because it's a closed circle?
Yes. Yeah, there's a bracket on the 3 and the -3 because they're closed.
I forgot.
And then here, because -6 is open, that's where you get the parentheses.
I
Yes.
forgot.
Why do you make it x is less than or equal to -3?
That was this part. Remember, this was a parabola, right? I just need to know when is this going to be positive? Or 0? Right? Positive or 0? It'll also be positive or 0 out here. Because like if I take -5 and square it, it's going to work still.